Okay, so my first test is just to simply see if the linear actuator works. So to extend, you actually have to reverse the polarity. So I'm going to connect red to black and black to red. And we're good to go. And in order to retract, we have to switch it back to normal polarity. And it looks like it works. So test 1 is complete. Okay, so So for test 2, we're going to see how long it takes to extend and retract with no load. And the way that we're going to time it is just by the timestamp on the video. If it's not noticeable within that range, then it's not significant enough to worry about. So I'm going to go ahead and start. And then now retracting. I'm going to redo the retracting because it's a little off. And it doesn't hurt to get a second trial in anyways. And here's the retracting again. All right, on to the next test. All right, so our third test is going to be half load. It's just an approximation. It's got a max load of 22 pounds, so we're going to do 10 pounds for the half load test. All right, and this is extending. Now we'll move on to retracting. All right. And now we're moving on to the fourth test, which is going to be fully loaded. It's got a max load of 22 pounds, like I said. So for the max load, we're just going to do 20. Let's see how she works. Here we go. As you can see, it's going significantly slower. All right, and now we're going to retract. think it drops a lot faster. We can check the timestamps, but that's test 4. And now we're done testing the actuator. Okay, so our next testing is going to be these relays. They're controlled from the SparkFun red board, and they're powered from the 5-volt output power on the red board. It's connected to DC plus on the relay board. And then this black wire is the ground and is connected to DC negative on the relay board. This first red wire is connected to N1, IN1 on the relay board, and it controls relay 1, which is connected to pin 13 on the red board. And this second red wire is N2, it controls relay 2, and it's connected to pin 7 on the red board. So first we're going to test relay 1. That constant clicking that you can hear is the relays turning on and off because of this code that's running. It turns relay 1 on for 3 seconds, then turns it off for 3 seconds, then turns relay 2 on for 3 seconds, then turns it off for 3 seconds. So we'll start out by using our voltmeter to measure the voltage across this battery. It's about 12.8 volts. Alright, so the way we've got it hooked up now, it's using two 10K resistors as the load just to be safe. I burn up a couple wires trying to connect it directly without a load before I learned that it needs one so you don't short the battery out. So yeah, or I guess realized is a better word. So if I connect the voltmeter to the normally open, you're going to see a voltage while the relay is off, but as soon as it engages, it closes the circuit and there's no voltage. So relay 1's normally open is working properly. Next we're going to check relay 1's normally. Okay, so normally closed should be just the opposite. While the relay is, while the relay is off, you should see 0 volts. And then wait about 3 seconds. When the relay is on, you'll see 12 volts. Alright, so relay 1 is working properly. I don't have all the parts I need to test the Bluetooth. However, there's one last test that I wanted to do, and that is to see if I can control the linear actuator with the relays, and the red board and the battery. So let's see. I'm going to be using the same code that turned relay 1 on for 3 seconds, then back off for 3 seconds, and then did the same thing with relay 2. And that's just going to keep running. So what you're going to see happen is the actuator open for 3 seconds, then stop, then close for 3 seconds, then stop. Alright, so what we have going on here with this configuration, it has the normally open of relay 2 connected to the normally open of relay 1, then the normally closed of relay 2 connected to the normally closed of relay 1, and the two commons come out and connect to our actuator, and our voltage source is going to connect to the normally open of relay 2 and then the normally closed of relay 1. So what this does is it has the circuit closed to one polarity when one relay is on and one is off, and then it has the circuit closed in a switched polarity when the opposite is on and the opposite is off. And if both relays are in the same position, as in both are on or both are off, then it's going to be an open circuit and the actuator won't do anything. So here we go. Let's see. I've actually had issues before. However, all it was a voltage drop issue. And that's all it was this time too. So here, I'm going to go ahead and clip these in a little closer to the actual conductors. As you can see, it is working properly now. So what happened was these wires right here, I don't believe they're copper, and they're also really small. So they have a higher resistance than these thick copper wires that I have from work. This is just some scrap wire that I had. I had the same issue when I was running this test at first without recording it. So all I have to do is just connect it more directly and get rid of that voltage drop, or use a bigger conductor. So now, as you can see, it opens either for 3 seconds or until it fully extends, and then closes. And that's it for the unit testing. And finally, for relay 2's normally closed. Alright, so it's got 0 volts. And now when it turns on, well, bummer. Try that one more time. Okay, so it's relay 2 is off right now. Got 0 volts. Turns on. We got 12 volts. So it's working properly. Now is the normally open on relay 2. And the relay just turned on, so it's got 0 volts. Turned back off, so there's now 12 volts. Let it cycle through one more time just to be sure. Turned on, 0 volts. Turn back off, back to 12 volts. Okay guys, so what this does is it is basically just a smart light switch. They're called relays, and they use low voltage controls, which would be these right here, to control a higher voltage, which is going to be this battery here, and you can use it to do a lot of things. I'm using it to control this linear actuator. Alright, and I'll just kind of give you an example of how it works. I'm running a code that closes this relay for 3 seconds, then opens it for 3 seconds, then closes this one for 3 seconds, then opens it for 3 seconds. So I'll go ahead and hook it up and show you just kind of what it does, I guess. And it's just controlling this guy. Yeah, and that's it. Just a smart light switch.